Alright, question 17. A set of 6 distinct, in bold, integers is split into 2 sets of 3. The first set of 3 has a mean 10 and a median of 8. The second 3 has mean 12 and a median of 9. What is the smallest possible range of the sets of all 6 integers? Okay, so it seems like the mean and the median of the second set is all greater than the first set, right? So probably the second set is going to define the upper bound, right? Defines upper bound as maybe upper bound. Okay. All right, and the first set probably defines the lower bound. Okay, so let's consider the first set first. Okay, so first set. All right, 3 numbers, median is 8, so 8 must be in the middle. Okay, so this set defines the lower bound, right? I want smallest possible range. So I want this number to be as big as possible. Right? Because I want the lower bound to be bigger to sort of to narrow the range, right? So biggest number 7, right? Because distinct integers, so I can only pick 7. So now I have a mean of 10, so the last number is 15, right? Because the sum of these 3 numbers must be 30. 10 times 3 is 30. So 30 minus 7 minus 8 gives you 15 there. Cool, that's my first set. Second set. So again, same idea, median is 9. So I want the upper bound, I want this number, upper bound, to be as small as possible. Right? Okay. I want this to be as small as possible, but of course I can't pick 10, right? Because if I pick 10, there's no way that I'm going to arrive at a mean of 12. Right? There's no way I'm going to achieve that. So instead of considering the last number, let's consider the first number, shall we? If you want the last number to be as small as possible, then you want the first guy to be as big as possible. Because you have a fixed mean, right? You have a fixed mean. So the mean is going to balance these numbers, right? So the third number as small as possible, then the first number has to be as big as possible. Good. So what can we pick? 8 can we pick? Well, not really, right? Because distinct. I can't pick 7 either, because again, I've used 7 in the first set. So what I can only do is the 6. Right? That's the best I can do. So 6 and a 9, what's the last number? So the mean is 12, right? 12 times 3, 36. 36 minus 6, 30. 30 minus 9, 21. So I can only do 21. All right. Good. Okay. So, good. Okay. So by me doing these 2 sets, what's my range? My range is 15, right? 21 minus 6 is 15. Okay. So is this the smallest set at all? So let's have a think. So, you know, I'm definitely using the 6 and 7, right? Because both sets need it. So is there any way that I could sort of lower this 21? How can I lower this 21? Alright, as I said, if you want the 21 to be smaller, the 6 has to be bigger, right? Okay, so then I need to borrow some numbers from the first set, right? I can't borrow the 8, definitely, because the 8 is the median of the first set, so the 8 has to be in the first set. Yeah, so maybe I could borrow the 7, right? If I borrow the 7, so this becomes a 6, say. Okay, so then I need to adjust some numbers, right? If this is a 6, then this must be 16 to compensate for the mean, right? To compensate for the mean. Second set, if that's 7, this can be 20, right? So now I've lowered the range by 1, right? Because now 20 minus 6 is 14, right? So could I go any further? Well, if I go any further, okay, if I pick like something 5, you know, it doesn't match the as big as possible assumption here, right? So 6 and 7 are already the biggest possible numbers I can pick on the left hand side. So this must be optimal. All right, so final answer, E.